Let's have a look at question 1 in this video. So we have two goods, X and Y, and we have that the supply is perfectly elastic, meaning that the price is fixed at 10 euros per unit. Now we also know the quantity demanded for X, the quantity demanded for Y. In part A, we want to find out the elasticity of demand for X and Y. So this is a pretty mechanical question in the sense that we just have to follow this method of finding the elasticity. Now, what is the elasticity in general? For instance, the elasticity of demand for good X. That's gonna be the price of good X in equilibrium divided by the quantity demanded of good X in equilibrium times the derivative of the quantity demanded with respect to price. So we know that we can find out the derivative of the quantity demanded of X from the function itself. That's just the slope of the function. So in this case, it's going to be minus 1 over 4. But besides that, we also need to know the price and quantity in equilibrium. Well, we know that the price is already going to be 10 because that's just given to us. Well, we will just substitute the price into the quantity demanded function and we'll find out what that is. So let's do so. What would be the quantity demanded of X? We're going to do it over here like that. The quantity demanded of X in equilibrium is going to be 22 minus 1 over 4 times the price of 10 euros. That's 22 minus 2.5, which is equal to 19.5 units. So we find out that it's 19.5 units. Now we have all the data to find out the elasticity. So let's do it over here below. The elasticity of demand of good X is going to be equal to the price, which we said it's 10, divided by the quantity demanded in equilibrium, which is 19.5, times this slope. And that slope we saw it's equal to minus 1 over 4. So times minus 1 over 4. Minus 1 over 4 over here. Now if we solve the math, what do we get? Let's see, 10 and 4 cancel out. These two cancel out and we're left with 2.5. So we have minus 2.5 divided by 19.5. That's equal to minus 0.128. And if we convert it, actually no, we don't have to convert it. That's already given in percentages. Meaning, what does this tell us? It tells us that when the price increases by 1%, when the price of good X increases by 1%, price of good X increases by 1%, the quantity demanded for X decreases by 0.128%. Hope this makes sense. Now, with the same logic, we do it for B. Again, the same mechanics, the same method. We will have the elasticity of demand for good Y. That's what I meant to say, for good Y, which is equal to the price of good Y divided by the quantity demanded of good Y times the quantity demanded of good Y derivative with respect to its price. So we can take that derivative from the function as well, because that's just the slope of the function, which is over here. I should have used a different color. Anyway, let me do it now. So over here, what is the coefficient? Well, that's just minus 1. This is going to be the derivative that we're going to use. Now, how can we find out the quantity demanded in equilibrium given that the price is fixed at 10 euros? We'll just substitute it into the quantity demanded of Y function. And if you do so, what's that going to give us? The quantity demanded of Y in equilibrium is 50 minus 10. That's equal to 40 units. Now, with all that, we can find out the elasticity of demand. So we keep in mind that derivative was minus 1, price 10, quantity 40. So it's a matter of substitution. We substitute it into our function over here. Actually, it's an equation, better said. And we will have the elasticity of demand for good Y is equal to that price, which is 10. The quantity demanded we found out to be equal to 40. So that's 40. And the slope was minus 1. So 10 over 40. 10 over 40, that's just 1 over 4. That's 1 over 4 times minus 1 is minus 1 divided by 4. And 1 divided by 4 is 0.25. So minus 0.25. How do we interpret this? The same way we interpreted the elasticity of demand for good X. If the price of good Y increases by 1%, then the quantity demanded of good Y goes down by 0.25%. When it comes to elasticities, the results are given in percentages already. The changes are in percent. Anyway, we're done with part A. In the next video, we go to part B.